Okay, let's make a flowchart for bisection method. Okay. So we start by specifying A, B and C tolerance, no? So we give A, B and tolerance, okay, or the error amount. Okay, so we start by giving these. Now next thing is to check here whether these initial values work. Okay, that means I have to check FA, FB, and FB less than 0. Okay, if it not, that means there is no root in this interval, is not a good point to start. Okay, so we return error. Okay, if it's true, we can continue. Okay, if it's yes, we can continue. So we can go into a while loop. Okay, so we will do while we will continue the loop while this absolute value of B minus A bigger than tolerance, no? Because if it's smaller, we don't have to give that, we are close enough, so we can take midpoint as the root, no? So then we will continue while this one should be while this is bigger than t, we continue. We say C equals A plus B. Okay, now we check for FC and FB. FA, and let's check sign of FA and FC. Okay, now root have to be either in this interval. So always according to what we saw, root when we have C, A and B, either root will be in this interval or this interval, no? So if it's in this interval, this will be less than 0. Okay, if A and FC less than 0, that means root is inside this interval. Okay, so we can forget about B, that means I can make B equals C. Okay, if not, root is in CB interval, then I can forget about A, like we did in that example, and make C A equals C. Okay, from here we can again continue here, keep doing this. Okay, when we come out of this loop, that means A minus B is less than tolerance, so we can give root as t, no? So when we come out of this loop, I can print c as my root, no? So there is one thing we need to amend in this code. What happens, c becomes the root here. When I calculate this, c becomes the root. Okay, so if c becomes the root, then this will not be 0. Okay, then this will make AC and try to continue, so that is an error. Okay, so for here, after soon as I calculate c, I will check whether fc is equal to 0. Okay, that case I already found the root as c, I have to stop. Okay, so here I can come to print root here. Okay, breaking out of the root. One more, is that clear? Okay, hope it's clear, because if we soon as find c equals this one, if it is the root, then this condition becomes false. So this is the root, I will try to get this and this at my thing, and I will try to look the root inside this interval when I already found the root. Okay, because of that, here a plus b over 2 is my c. Here I have to break out of the loop if fc is equal to 0. Okay, so all that. One more thing, if my original a and b is less than the tolerance, it will no. Okay, so when if fa and fb are like negative and it comes here, and if it less than the tolerant, it will try to print c without calculating the c here. Okay, so here also I will put a calculate c false. Okay, c equals a plus b over 2. Okay, because here I will not go to the loop. So here if I go into the loop, it will calculate c a plus b again. It only happens once, this additional calculation, so it doesn't matter. So I will put a calculation here also. Okay, it will, if I come into the loop, it will calculate this c a plus b twice. That's okay, it's only once. Okay, because after that I'm going inside this loop again and again until I break out from here, or I break out from here. Okay, hope this is clear. So okay, let's now type a Python code for this one. Okay, so you can go ahead and type the Python code. Okay, by pausing this video, you can type the Python code for exercise 1 in the homework section. Okay, but I will show that code here. Okay, so let's go to Spider. Okay, so first read the homework problem before trying this. Okay, and try it yourself, and if you cannot do it, look at the code, it's better. Okay, so here, according to the homework problem, we are supposed to write a bisection method for the function x squared, solve the equation x squared this equation, no? Okay, x squared minus 2 equals 0. Okay, you can solve this by hand. We know the root 2 is the solution. So as first exercise, I give you a function where we know the root, so we can compare, okay, our result with the actual root. Okay, so we will implement this method. Okay, so before implementing this method, I have to implement that function. Okay, so in bisection method we have to identify this f function. So to identify that f function, okay, sorry, that f function is going to be the function so that fx equals 0. Okay, so if I pick this to be my function, fx to be x squared minus 2, that will be my fx. Okay, so in this loop I have to calculate fx several times, no, fa and fc. Okay, so because of that I will make it a function first. Okay, so I will do the definition. Okay, this should not be coming. Okay. Still coming. Sorry. Okay, dot string. This 3 coming is that. Okay, so definition, I will define my function to be f, so I can naturally call it. Okay, so this f is my new function name, and I'm going to pass it a one variable. Let's call it x. Okay, and we are going to turn okay, so here when I call f, it will return the f squared value. Okay, so for example, if I do string f of 2, it should return 4, no? Let's see. Oops, what happened? No, sorry. Okay, I should have said star. I accidentally used the one for MATLAB. To square, I should use star. Okay, so it returns 4. Is that correct? Okay, is that clear? Okay, sorry, I will use that MATLAB symbol. So for square, I should use star. Okay, and not x squared. My function is x squared minus 2, no? So I should do this. Okay, so that should give me a 2. 4 minus 2, 2. Okay, so that here I constructed my function. Now I will construct a function for bisection method. Okay, I will give the function definition. Bisection. Okay, I am going to pass in the values for a, b and the tolerance. Okay, I will say t, tolerance. Okay, so this is my definition. Inside, first thing is to check whether fa minus fb is equal to 0, no? So I will check if f star fa star fb less than 0. Okay, if it's not less than 0, it's error, no? I should return error in that case. So here I will say else else return error. Okay. Now here if FA is less than FB, we can go into this while loop. Before that, for that precaution, I calculate C here. It gets duplicated, no, but C equals A plus B. So here first I have to add, no, to find the midpoint, and then divide by 2. So I have to change the order of operations to add, to give the precedence for this add operation. So I put a plus B, okay, divided by 2. Then I go for while loop. While normally when we pass A and B, we expect B to be bigger than 0, no? But in case if it's smaller, we have to use the absolute value here, okay? So let's check how to get the absolute value in Python, okay? So let's go here, internet here, let's go to Google and check. X function, okay. Okay, we can use X0, okay. So we can easily use X function here, X function. So I will do X, I will say B minus A, okay. Bigger than tolerance, no, if it's less than tolerance, I can use C as my root. Bigger than tolerance, so that is this part. C equals A plus B over 2 earlier, no? So here I am doing C equals A plus B over 2, okay? So this one get duplicated one time only, because after that it's going in this while loop, so we will not worry about that duplication. Now we have to check what happens if C is less than 0, no? Equal to 0. If it is equal to 0, that means we have to break out of the root, no? So here if FC equals to 0, I have to break out of the loop. So there I can use a break statement to break out of the root, okay. So here I should use if condition also. If, okay, FC equal to 0, I break out of the loop, break. Here I can use a else statement, or here I can directly continue to my program also below, okay, because I will come only for this situation if FC is not equal to 0, because FC equal to 0 I will break out of the loop. So here I can type the normal code. So after that, so here I have this FC equal to 0 breakout condition. Now I have to check FA equals FC less than 0. Okay, so again here I check times FC this time, no? C less than 0. Okay, so in this case FA equals FC less than 0. That means my root is in the AC interval, so I have to drop the B. So I said B equal to C. I drop the old B value, no? So I says B equal to C. Here else part of this root, here this else, no? Else part of this line, I should say A equal to C, no? Otherwise I am going to drop, sorry, A, no? I am going to smooth my A and drop the old value of A by storing C in A. Okay, so I keep doing this one. At the end, outside of all these, I am going to return I did one mistake. I forgot to do this one, no? Because this while have to be inside this have to be indented here, this have to be indented one level down, sorry. Okay, so this is okay. This one have to go one more level. Okay, that's correct. This else is the else of this one, so it have to be same as this is. Okay, how that is and AC is here. Okay, now inside this, if I have to return outside of the loop, no? That means outside of the loop I keep same indentation level here. C is my root, no? I am going to return C, so that is outside of this loop. Okay, so this is my code. Now to solve, if I look at this, okay, this is actually square root 2. Okay, if you look at here, see this y equals x squared minus 2. This is the root of square root 2 1.41 something. Okay, so here I can starting value I use 1 and 2 because root is contained in 1 and 2. So here I will give starting values 1 and 2 and call my function. Okay, so let's say here I will call bisection this guy, no? So A I will say 1, B I say 2, my tolerance I can say 1. Okay, I will, so my error can be, maximum error can be here 0.1. Okay, so we run this and see. 1.4375, no? So it's a small error about 0.1. Our error is 0.4, so this is less than that, no? So actual root is 1.41 something, so that this is like so if I make this one further small, it will take more time to run, but I can get a better approximation. See, if I make it further small, it will take more time to run and I will get a far better approximation. So making this tolerance smaller, I can get a better approximation. So my bisection method runs just to see the situation where I give a interval without a root. If I look at here, 1 and 0 don't have a root, no? If I give 0, 1, it should return an error. Okay, let's see. I give here 0. Error. Okay, see, giving me error because there is no root in that interval. So this is fine. Okay, so like before, I can try 1 and 2. Let's make it really small. So, okay. So that is our bisection method code. Okay. Hope this is clear. See you in the next video. So one more thing, observe that when I go in this while loop, this thing don't get executed again. This one is the one keep getting executed. Okay, so this gets only duplicated once. Okay, I explain why I had that there.